Let's talk about skew. What is it? Well, it's misalignment of the two signals as they arrive at the receiver. They arrive at different times. I'll again review how differential pair operates, and you can see where that comes into play. Again, you remember we decide we have a logic state change when the two signals cross. And as you know, differential protocol is the technology of the 21st century. All the internet runs on copper is relying on differential signaling. Again, we wouldn't have it, the internet without it. We have in the lab, it's hard to believe, but we have in the lab 64 gigabits per second. Actually, we have prototypes. In the lab, we have one place where, and I said I was going to quit when this happened. In the lab, we have one place where we're running 100 gigabits per second over copper. So maybe next year I won't be here. Maybe that's my signal to retire. Anyway, small variations of laminate at those speeds can turn out to have big side effects that are negative. And skew is the big one. We earlier saw that we can tolerate huge amounts of loss now. So that has dropped down in the list of things to worry about. And two that are at the top now are skew and crosstalk. Those are at the top now. So where does it come from? Well, something caused the two edges to be misaligned at the receiver. If they were not aligned when they left the package, that would be one source. If the lengths on the board and the connectors were not the same, that would be another. Difference in flight time in the laminate would be a third one. And all that modern ICs I know about, they are doing such a good job matching things that a picosecond is about as much error or difference as you see leaving ICs. And you all are good at layout, so you can do that length matching on the board to a picosecond, or you think you can. Where we might have a problem is the glass weave. And on the test boards that I've been citing, we got a shock because we had thought we had really uniform glass, and we wound up with one path 14 inches long with 62 picoseconds of skew.